Welcome to your video on graphing quadratic inequalities. Much of what we're going to talk about today is going to sound familiar. You're going to recognize both standard form and vertex form, but we're going to add in the new piece with the inequalities. So the first thing I want to look at are just a review of what the inequality symbols are. So we've got kind of two sets here. The first set is the greater than or the less than symbol. And if you think about when we used to graph just on a number line, we would make an open circle for those symbols. On a graph, when we've got y's and x's, we're going to use a dashed line, or in the case of graphing a parabola, a dashed curve. With the other symbols, the greater than or equal to or the less than or equal to, if you think back to the number line, we used to do a solid circle. So now on the graph, you're going to do the same thing. You're just going to make a solid line, or in this case, a solid curve. So like we've been doing. Now, when you're going to make a graph, you're going to follow many of the same steps that we did before with both standard form and vertex form. And step one, as you may recall, is to find the vertex. Now, we do have two different types of equations, so you're going to have to recognize which type you're dealing with. So the first would be to recognize standard form. And hopefully you remember that standard form is y equals ax squared plus bx plus c. And to find the vertex, you're actually going to go through the axis of symmetry and find that x is negative 1b over 2a. And then obviously you would get that x coordinate and plug it in for y. If you have vertex form, you will recognize it as y equals a times the quantity x minus h squared plus k. And to get the vertex with this form, it's a little bit easier. You just have to recognize the h and the k. The one trick, like we talked about in class, is to remember that that h value is always going to be the opposite of what you see in the equation. Once you get the vertex, step two is to make a table. And the key with your table is to make sure that you put the vertex in the middle. If you think about the vertex being the middle of your graph or the middle of your parabola, that should help you remember that the vertex should be in the middle of the table. And then from there, you're going to pick your points around it using the symmetry. So that's kind of where the old stuff ends, and now this is where the new stuff begins. Once you get your ordered pairs, usually we've done 5 points that we're going to put on the graph, you have to know how to connect them. So you're going to have to decide, is it going to be a dashed parabola or a solid parabola? And to do that, you're just going to think back to those inequality symbols that we reviewed at the start of this lesson. Once you've determined if it's dashed or solid, you also have to do some shading. So now you're going to have to think about, is my symbol greater than or is it less than? And so if it's greater than, that means you're looking at all the points that are above the curve. So either the greater than symbol or the greater than or equal to symbol are going to mean that you shade above the parabola. Shading below the parabola will be indicated with the less than symbol, so either less than or the less than or equal to. And if you're a little unsure about what this means, don't worry, we're going to go through plenty of examples so you get the hang of it. Our first example, you are actually looking at a graph that is already made for you. We have the parabola drawn in. You can see the vertex there at 2, negative 2. You can see that it is a dashed parabola. And if you look at the inequality written above the graph, you'll notice that we just have the greater than symbol. So just because it's greater than by itself with no equal bar, that tells us that it's dashed. And then if you think back to what we were just talking about with the shading, we shaded above the parabola because we had the greater than symbol. So what we need to talk about now is what is actually a solution to an inequality. So in part A, we want you to name 2 points that are solutions. And you can think about a solution as any point that falls in the shaded area. So if you just look at where it's shaded pink, you can pick out any of the ordered pairs. So for example, 0, negative 2. If we put that point on the graph, you'll note that that's in the shaded region. So that would be one example of a solution. Another could be 3, negative 1. That's also in the pink area. So that would be a solution. Now, you'll note that there are an infinite number of points in the shaded region, so there are a number of correct answers. These are just two possibilities. In part B, we want to look at 2 points that are not solutions. So that means they cannot be shaded. So one example would be 2, -4. So I just kind of put an X there saying, okay, this is not a solution because it's not in the shaded region. Now here's kind of an interesting point. The fact that our parabola is dashed means that none of the points on the curve are considered solutions either. So if you look at where I said the vertex was at 2, -2, that is not a solution. And the reason it is not a solution is because it is a dashed parabola. Now on the flip side of that, if we had a solid parabola, then all of the points would be considered solutions. So they're kind of put together with that shaded region. Our next example, we are asking you to finish graphing the quadratic inequality. So we've actually done the hard part for you. We found the vertex and we found all the points and we've graphed the points for you. So you just have to figure out how are you going to connect those points. So are you going to have a solid or a dashed parabola? And then where are you going to shade? And the inequality symbol is going to tell you all of that. So the fact that we have the equal bar underneath it tells us that we are going to have a solid parabola. So we can go ahead and connect those points, making a smooth curve, just like we normally would. The fact that it is less than tells us that we need to shade below the parabola. All of the points below it are going to be solutions. So you can either just kind of do what we're doing here and just do the slants. If you've got a highlighter, you can use a highlighter. If you want to get out colored pencils, you can get out colored pencils, as long as you get the point across that you're shading below. Our next example, you're going to have to actually go through the entire process of graphing this inequality. So the first thing I want you to note is that the equation is written in standard form. And the reason we know it's in standard form is because of the way that it is set up. We don't have the parentheses. So we're going to look for the A, the B, and the C. Our A value is 1, our B value is 7, and our C value is 10. And again, we're going to use the ABCs to get our axis of symmetry. So we're going to go through that formula, -1 times B divided by 2 times A. And for this one, we come up with a -3.5. which is fine. I think we've talked about graphing with decimals before. So we'll go ahead and draw our axis in there at x equals -3.5. And that's going to tell us we know the line where our vertex is going to lie on. So again, this is not new. After we have the axis, we need to take that value and we need to plug it into our equation. So we're simply just substituting in the -3.5 for all the x values. And here's where you would just get out your calculator. In fact, you may want to press pause and actually try this on your own. And once you do, you will find that y is -2.25. So we can go ahead and graph our vertex now at -3.5, -2.25. Okay, and again, don't worry too much about the decimals. It just means you're going to go down 2 units and then a little bit further. So now we're ready for our table. And remember, the vertex is going to go right in the middle. And because we've got these decimal numbers, I was a little bit thoughtful about how I was going to make the table. I certainly don't want to be plugging decimals into my equation the entire time. So I picked the next closest integers to -3.5. So I will use -4 and I will use -3. But then because these are so close together on the graph and I want to make sure that I get a nice picture and get a full U, I'm going to go a little bit further away. So instead of going up by 1s like we normally do, I'm actually going to go by 2s. So I'm going to go out to -6 and then -1. Okay, so here, at this time, you should press pause and you should try plugging in each of these values. Remember, you only have to plug in the -6 or the -4, or the -3 and the -1, either pair. And just test those out, make sure you can get those right answers. Once you've plugged them into your equation, you will find out that we get the points -6, 4, -4, -2. And then using symmetry, we know that it's going to be -2 and -4, or +4, I'm sorry, +4 on the other side. So we're going to go ahead and just plot those points. And we're not going to connect them just yet because we have to think about, are we going to be using a dashed or are we going to be using a solid parabola? So what we need to look at now is the inequality symbol. And you'll notice that it is the less than symbol. It does not have the equal bar underneath it. So it will be dashed. And because it is less than, that means I'm looking for all the points that are less than my parabola. So what that means is we're going to be shading below. So anything underneath the parabola is where we're going to find solutions. So you're just going to, again, make some slashes, use a highlighter, use your pencil, use a marker, colored pencils, however you want to do that. Okay, so the first part of it should look very familiar. The only new thing we're doing is we're looking at either dashed or solid, and then shading above or below. Our last example, hang in there with us here, you will note should go a little bit quicker because we are dealing with vertex form. The key there is that we've got the parentheses. So with vertex form, we start with the A, the H, and the K. You'll notice that the number in front of the parentheses, we don't really have one there, so we know that that's our invisible 1, so A is just 1. Our H value is a positive 2, because note inside it's x minus 2, and we always look at the opposite. And then our K value is 3. From there, we know that our vertex is at the point 2, 3, and we can go ahead and graph that. And put in our axis of symmetry. Now, from here, we're going to make our table, our XY chart, remembering that our vertex is going to go right in the middle. We've got 2, 3. And then we're just going to pick points on either side, and here we can go pretty normally, just go up by 1s. And then again, we only have to put in half the points, either the 0 and the 1, or the 3 and the 4. So at this point, I'd like you to press pause and use your calculator and just try plugging those numbers in. And once you've done that, you will find that you get 0, 7, 1, 4, 3, 4, and 4, 7. So again, we go ahead and plot these points. And to determine if we're going to connect them or how we're going to connect them, we will be connecting them. You again have to look at your inequality symbol. So with this one, we notice that we have the equal bar underneath it, which makes it a solid parabola. So we could go ahead and connect those just like we were before. And because of the greater than symbol, we need to be shading above. We're looking at all points that are greater than our parabola, which means they're going to be above it. So you're going to be coloring on the inside this time. All right, this concludes your video. You are now ready to start the practice. And as always, when you have questions, please see your teacher. Cool.